Give Academy. In this lesson, we are going to talk about illuminations in brief. So, in this topic, according to the syllabus, then we are supposed to start with the definitions of some terms. So, in illuminations, there are terms which we shall come across. So, it is very important to define them. So, this topic of illumination has got some few terminologies. So the first term is known as, so we start with the definitions. Definitions of terms. So the first term is the illuminations. Number two is known as luminous flux. Luminous flux. 3, we're also supposed to define another term known as luminous intensity. Luminous intensity. 4, we are supposed also to define the term candela. Number 5, we're also supposed to define the term known as luminance. 6, deluxe, and so forth. So there are many terms, but based on what we are supposed to do, we are narrowed to only these few terms: illuminations, luminous flux, the luminous intensity, the candela, the luminance, and finally the lux. So when we say the illuminations, what we meant? So illuminations, for the purpose of the mathematical problem which we shall come across, then the illumination is denoted with letter E. It is denoted with letter E, and that illuminations means the incidence. It is the incident luminous flux per unit area surface. So illuminations is defined as the incident luminous flux by unit area of surface, and it is measured in the SI unit. The SI unit is lux. The SI unit is lux, or the lumens per meters square. Per meters square. Then we go to the luminous flux, and this one is defined as the flow of radiance energy evaluated according to ability to produce a sensations of seeing. So that one is it is the measure of the flow of radiant energy evaluated, and that is actually according to the ability to produce the sensations of seeing. That one is the luminous flux, and the SI unit of that is measured in lumen. So this one is measured in lumen. So that one, it is the ability to produce sensations of seeing. And then we also supposed to look at the luminous intensity, and this is it is defined as the flux emitted in the surface. It is the amount or the flux emitted in the surface or a solid angled by a uniform point source. Now this one is also measured in candela, and this one is measured in candela. So density, we are saying it is the flux emitted in the surface or a solid and that one in respect to angle by a uniform point source. By regulations we shall see how we can determine that, and it is measured in the candela. And then we have the candela. Candela is used to measure the luminous intensity. And then we have the luminance. This one we are talking about the brightness. So we can just say luminous intensity. This is the brightness. And this one, it is used to measure. So used to measure illumination. So lux is used to measure illuminations. So we've got these terms, which in most cases you are required to know them for the purposes of maybe exams. Most of the exams, when you are doing illumination, these are some of the terms that you might come across. And usually in most of the exams you are being asked to define and to give them in the SI unit. So we've got the illuminations, we have the luminous intensity, the luminous flux, the candela, the luminance, and then the lux. Now, the second subtopic is the law of illuminations. So the second subtopic is the law of illumination, or the laws of illumination. One, we've got two laws. The law number one is known as the inverse square law. Inverse square law. Number two is the cosine law. So the law of illuminations, we've got those two. One, of course, is the inverse square law, and the other one is the cosine law. Is the cosine laws. So let's start with explaining the inverse. So the first one is the inverse square law of illumination. This one states that the illumination is directly proportional to the intensity of light, and inversely proportional to the square of distance. So we are saying the illumination is directly proportional to the intensity and inversely proportional to the square of distance. So illumination is directly proportional to the intensity and inversely proportional to the square of distance. Now, so we say, according to this formula, we say illumination is directly proportional to the is directly to the luminous intensity, and inversely proportional to the square of distance. That is the formula. So illumination is directly proportional to the intensity and inversely. So this one is a illumination is directly proportional to intensity and inversely proportional to the square of distance. So it can be summarized by that formula. So that is the inverse square law of illumination. So it says the illumination is directly proportional to intensity and inversely proportional to the square of distance. So that is the formula. So now the illumination will be equals to, we can say illumination will be equals to force all over the area. F all over that. So for example, if we have F, area is usually 4 pi r squared, n per meters square. So we can also further say, since F and pi, 4 pi are constant, therefore illumination will be inversely proportional to the radius square. So since F and 4 pi is constant, then we can say illumination is inversely proportional to the square of radius. Inversely proportional to the square of radius. So that is the law of inverse square law of illuminations. It is this. So it means the illumination is directly proportional to the density and inversely proportional to the square of distance. That is the inverse law. Then secondly is the cosine law. So the cosine law states that the illumination produced on the surface by point light is proportional to the cosine angle of incident. So illumination is therefore equals to intensity all over the square of distance multiplied by the cos angle. For example, we have the light here. We have the light source here. this is the working service. Then is equal to that angle. So this is going to be our light source, and this is the one we are calling it radius. Is that at angle. So this is the height from the ceiling, and this is the working area, and then that one's become the radius, or from mathematical knowledge is called hypotenuse. So let's see some examples. Examples. So we are taught here to determine the luminous flux required to provide an illumination level of 200 lux in a room measuring 8 by 5 meters if the utilization factor is that. So from the formula, if we want to get the number of the lamps required to illuminate that room, then we usually say the illumination multiplied by the area all over the luminous intensity multiplied by the utilization factor multiplied by the light factor is given by this formula. So we can start by stating what is A. A is the area, E is the illuminations, A is the illuminations, F is the luminous flux, UF is the utilization factor, LF is the light loss factor, light loss factor. determining the luminous flux, we are going to write the formula F is going to be equals to E F equals to end multiplied by utilization factor multiplied by light loss factor, which are going to get the area, of course. Area here is going to be 8 meters multiplied by 5 meters is going to be 40 meters squared. So the illumination, we were given the illumination to be 200 multiplied by the area, which is 40 all over. The number of lamps required to illuminate that area. We can take n to be 1 for calculation. So 1 multiplied by utilization factor 0.7 multiplied by 0.8. So from the calculation from your calculator, you are supposed to get something like 14,285.1 lumens. Then, how do we determine the number of lamps? Determining the number of lamps is going to be equal to total lumen all over lumen per lamp. So the total lumen is 14,285.71 all over. The lumens per lamp is going to be 300. If we have a room like this, then we are told, then we have 5. So 300 and 400. The lunas is 200 lux. So by calculations, we are going to get 4.3 lamps, which is equals to 5 lamps. Is equals to 5 lamps. It is equals to that. Okay, after that we can't end there until next class, when we shall come to look at the examples of examples when it comes to the cosine law. And then from there we are supposed also to design those lamps according to the room. So one, we are supposed to know the number of lamps required in a room, and then how do we arrange them in a room for better